In this video, we will look in simple terms how an electric motor works. You may wish to view these videos before we begin. You will have seen described before what happens when a wire carrying an electric current is placed in a perpendicular magnetic field. The direction of the field can be shown by Maxwell's corkscrew rule. If we add more wires, the resultant magnetic field builds up and becomes stronger. Placing these wires perpendicular to a magnetic field enables us to see how these force lines interact. Let's look at this setup from a different angle. Here we are looking down the wire. We can see a cross-section of wires and the magnetic field running clockwise around it. Now we can see the permanent magnets and the magnetic field between them running from north to south. These magnetic fields interact.
Above the wire, these two fields run in opposite directions and so cancel each other out. Below the wire, the fields run in the same direction and reinforce each other. The wire is pushed away from the strong field towards the weak one.
So the wire will be pushed vertically upwards out of the magnetic field. This is the motor effect. Now, reverse the current. This experiences a force in the opposite direction. Now, place both wires in the same field. One wire will be pushed up, the other down, but we don't have circular motion yet. Now, if we link the wires together and then insert a spindle to allow a rotation, we convert the opposing up-down motion into a rotation, and here you have an electric motor. Looping the wire around many times will increase the turning force on the motor. The clever bit is how to supply a current to a spinning coil so that it always flows in the same direction, ensuring that the upward and downward forces are always on the same side. This is done with a split ring commutator, but the exact details as to how this works we can leave for another time.